Hi, my name is Kayla, and this is my vascular system project. For materials, I use styrofoam for the organs, and I use red and blue pipe cleaner to represent the arteries that supply oxygenated blood and the veins that supply deoxygenated blood. So at the top we have our heart that pumps blood throughout the body. To the left here we have our aorta, and to the right here we have our IVC, so our inferior vena cava. Here we have our liver, which is the largest internal organ of our body. It has over 500 functions, including formation and secretion of bile, metabolism of fat, protein, and carbohydrates, as well as detoxification and lymph formation. So the liver receives a double blood supply, one from the hepatic artery, which you can see here, which provides oxygen-rich blood, and the portal vein, which you can see right here, that supplies nutrient-rich blood. They mix together and they're drained into the IVC by the hepatic veins. Okay. So the common hepatic artery, as you can see right here, it's the red one. It branches off the celiac trunk towards the right of the liver, to the right towards the liver hilum, and then further branches into right and left hepatic arteries to supply blood to each lobe of the liver. So the main portal vein, as you can see here, it's formed at the junction of the superior mesenteric vein, which is right here, and the splenic vein, which is right here, at the portal confluence, and travels towards the liver and enters the liver hilum into the porta hepatis, and there it divides into the right and left portal veins. So the hepatic veins drain directly into the superior aspect of the IVC. The right hepatic vein is the largest, and it separates the right lobe into anterior and posterior segments. And the middle hepatic lobe is located in between the main lobar fissure, and it separates the right and the left lobes of the liver. And then lastly here we have the left hepatic vein, which divides the left lobe into medial and lateral aspects or segments. Okay, so then next here we have the stomach, which stores the food we eat and breaks it down with acids and enzymes before releasing it into the small intestines or the small bowel. The left gastric artery, as you can see here, branches off the celiac axis or the celiac trunk and enters the stomach at the fundal portion to supply blood to the stomach and the esophagus. Okay. Next here we have the spleen, which is right here, which is mainly for reserving, filtering, producing, and defending blood products. It's a main part of our immune system, or immune responses, and it's highly vascular, and it receives its blood supply from the splenic artery, which also comes off of the celiac trunk. The splenic artery courses along the superior border of the pancreas until it reaches the splenic hilum. And then, as you can see on the back, the splenic vein originates at the splenic hilum, where it then exits and travels posteriorly to the pancreatic body of the pancreas, where it meets the superior mesenteric vein, as you can see right here, behind the pancreatic neck, and joins with it to make the portal vein. So then next here we have the pancreas, which produces hormones such as insulin, glucose, and somatostatin, and it also creates enzymes that aid in food breakdown, digestion, and absorption of essential nutrients. It receives its main blood supply from the splenic artery, which is the third branch of the celiac trunk. The pancreas releases deoxygenated blood through the pancreatic veins that drain into the splenic vein. Okay, so now here we have the kidneys. We have our right one right here, and then we have our left one here. The kidneys function to remove waste from the blood and regulate its fluid and electrolyte content. The renal arteries supply oxygenated blood to the kidneys. They come from the lateral aspects of the aorta, so as you can see here, off the lateral aspects of the aorta. The right renal artery is longer because it travels further as it's further away from the aorta. And then the deoxygenated blood from the kidneys are from the renal veins, which are blue here. The right renal vein is shorter than the left because it's closer to the IVC. And the left renal vein courses anterior to the aorta and posterior to the SMA, which compresses it, giving it a nutcracker appearance before entering the IVC. Okay, so then lastly, we have the large intestines and the small intestines. The small intestines breaks down food, absorbs nutrients, and moves contents through the bowel through peristalsis. The large intestines' mainly function is to absorb water and electrolytes from undigested food and produce or form stool until it's released. The main blood supply from these organs are from the superior mesenteric artery, which you can see right here, which travels posteriorly. It travels posteriorly from the pancreas and it comes anterior to the uncinate process. The SMA comes off the abdominal aorta approximately like 2.5 centimeters below the celiac trunk. So the last vessels I want to show are the iliac veins, which are blue here, and the iliac arteries. At the bifurcation of the iliac arteries is where the abdominal aorta ends. And at the bifurcation of the iliac veins is where the IVC begins, and it travels superiorly until it reaches the right atrium of the heart. Overall, making this vascular system model has helped me understand how and where the different arteries and veins are laid out and which organs they supply blood to. I feel like it will help me with my scanning as I can use them as landmarks when doing my protocols. Thank you.